Hi everyone, welcome back to my YouTube channel. And today I'm going to discuss the second problem of the code process round like today's code process round Pinley round 2 division 1 plus division. Like this round is rated for both division 1 and division 2. Yeah, like the second problem is that you are given a permutation of size n. Permutation means in that array all the number between 1 to n exist exactly once. Okay, and you are allowed to do the operation of this type, and after that operation of this type means just consider this case. This is 4 6 4 3 5, and this is 2, and this is 1. Okay, so and the operation is that just choose one number between x to one number between 1 to n, right? And after that let's just choose this number 3. Okay, so x you can choose any number between 2 to n, and here the n is 6. Okay, so I can, okay, let's just choose the number 3. And after that what you're gonna do is that just find all the number which are less than 3. The number which are less than 3 is 1 and 2, and just write that 1 and 2, and without changing the order of occurrences of 1 2, because in my original array, on original array, 2 2 appear first, so I have to write 2 first, then 1, and after that I write all the remaining number, keeping the order same. The order is that 6 4 6 4 3 5, 6 4 3 5. So in that case he choose 4. So he write 3 2 1 C, and then 6 4 5 right. So you are allowed to perform this type of operation. This is called, yeah, like this is called one operation. Choose a number and arrange the permutation in this way. This is called one operation. So you have to tell that what is the minimum number of operation. After that you will get the permutation like this way: 1 2 3 4 5 6. That means all the numbers should be in ascending order, right? So yeah, like you have to tell what is the minimum number of operation. After that you'll get this type of permutation. Yeah, like this is the problem statement, and yeah, and see like see how to approach this problem. So basically in this type of operation you just have to, sorry, basically in this type of problem you just have to focus on the uh, let me plug my charger. Okay, so you have to, in this type of problem you just have to, um, at first you just have to focus on the type of operation, what you are doing. So okay, so just take one example that will be pretty much clear for you. Just okay, so this 6 4, yeah, like this example is good. The 1 2 3, the third example, uh, the same example. Okay, so we'll try one thing that this is not in ascending order. So at first we just try to arrange this formattation in ascending order, and just observe, yeah, like we'll try to observe what are the things that. Okay, so the permutation is 6 6 4 and 3, and this is 5, and this is 2, and this is 1, right? And um, our our required permutation is 1 2 3 4 5 and 6. This is our target permutation. This is our target permutation, and this is the given permutation. Okay, so can I use this thing? Okay, now see, I just want to 6 to be in last, right? uh, and this is the greatest element between all the elements, so the 6 should be present at last position. and but 6 is in present. So if I choose 6, so in this case it is better to choose 6, because just think in greedily. Okay, so I did like I just try to think this thing in greedily. So just try to think this thing in like layman way, normal way. So I have to place I have to mm, bring that 6 to the last position. So for that, what I can do is imagine like just okay. So yeah, like for that I have to at first you have to I have to choose 6. Okay, so if I choose 6, then the in this case the chosen number is 6, and then my permutation will become this is 4, this is 3, and this is 5, and this is 2, this is 1, now this is 6. Okay, and uh, after that now is this permutation in correct way, correct order? No, it isn't, like it is not. So in the second last position 5 should be present, like 5 present होना चाहिए था कि नहीं, तो नहीं है. So what we'll do is uh, how to bring that 5 to second position. So if I choose 5, right, if I choose 5, then all the elements greater than equal to 5 will arrange in last, like uh, all the element greater than in 5 will arrange in the last, and all the element are less than 5 we just put all the element less than 5, keeping the order same at first, and all the element greater than equal to 5 keeping the order same last after that. Okay, but here you can just imagine in this way, like just observe that if I choose 4, so if okay, so if I choose 5, is it okay? Like it is okay. You will get like this string 5 6 4 3 2 1. You will get this string. But just observe one thing, that okay, so if I choose 4, then what will happen? If I choose 4, then 4 5 6 obviously, like if I choose 4, then what will happen? If I choose 4, then 4 5 6 will come last. 4 5 6 will come last, and then the remaining element, that is 3 2 1. Remaining element 3 2 1. And in this way, you like what you have done, like you just reduced one operation. Are you getting like many? Are you guys getting my point or not? Like you just reduced one operation. So if I choose, if I choose 5, then also I'll get like 5 6, then 4 3 4 3 2 1. Yeah, and if I choose 4, due to this condition, the condition is that 4 is present before 5. That's why we are like uh, that's why we just in this case we are able to choose 4, and that will keep the remaining element in correct order. So this is the observation. If one element is okay, so yeah, like in this case we choose 4, right? Now this is my permutation. Now I have to choose 3, and if I choose 3, then 3 4 5 in this way. But okay, so if I choose 2, then what will happen? Just see. If I choose 2, then this will become just a second. Okay, this is become 1, and it become 3 2 4 5 6. But it is not in the ascending order, and it can't be like, yeah, like it is not in ascending order, so that's why we have to choose 3. Right, that's why I have to choose 3, and if I choose 3, then 3 4 5 6 uh, is in some if I choose 3, then this is 3, and now it becomes 1 2. So if I choose 3, then I'll get this order. So what you have observed in this case, that here whenever this condition is satisfied, the condition is that x plus 1 element, x plus 1 is greater element, and x, this is the element. Okay, let me write in different color. This is x plus 1. X plus 1 is a value, right? And this is x. This is so if this element, the greater element is if the greater element is present before the smaller element, this x, at that case I have to apply one operation. I mean, that is the observation. So if the greater element is just present before the smaller element, at that case I just have to increase, like I just have to add one in my answer, because I have to, at any cost I have to perform the operation. Because just think in greedily, because at the end you have to, I mean, at the end, like if it becomes like 1 and 3, 2, 4, 5, 6, then you after that you have to, like at any cost you have to perform this operation, like you have to choose this two, like there is no other way. If you not choose, uh, okay, so if you do not choose two, then you'll not able to make all the element in ascending order, so you have to choose two. So there is no other way, so that's why if this condition is satisfied, just increase the answer by 1. If the greater element is just present before the smaller element, then you just have to increase your answer. So like that what I did, or what I have done. So just see the solution. That here this is, I took input n, and this is arr of n plus 1, and okay, so I just take all the element from 1 to n, and this is 1, yeah, and this is CNT. The CNT will indicate that how many steps I have to apply, like what is the minimum number of steps. By using those steps, uh, I'll get the correct order of the sequence. Okay, so this is n, and I just check that this is the greater element, right? I means n, I minus 1 means n minus 1. If the greater element is just present, this I is present and the lesser index than this error of I minus 1, the smaller index, just before the smaller index, then just increase the CNT plus 1, because error indicate that position of the element. 2, error of 2 indicate that 2 is present in 2 is present in which position. Error of what, yeah, like error of 3 tells you 3 is present in which position currently. Okay, so yeah, and you guys can ask me one question, like why did you take the currently or adjacent element? Okay, right. So here I am taking n minus 1, n minus 1, n minus 2, n minus 2, n minus 3, and this is like this type of question may arise in your mind, but let me just clarify that why I took this way. And the element is like 6, 4, or something like 3, 5, 2, 1, I guess. Because at first how I thought, like, yeah, like how did I think, at first how did I think is that uh, at first I just try to 6 to be in its position, then 5 to in its position, like I just want to place the 6 in its actual position, and then I just tried to place the 5 in its actual position, then 4 in for its actual position. So I just try to place this like just try to place the grid daily, because if you tried a lot of examples, then I think you can more better, you can feel more better. But yeah, like I just try to place the adjacent element if those element are in, I mean, yeah, like you can observe, I think you have observed from my dry, like while I'm doing the dry run, that every time uh, I just want to make the permutation in increasing order from last. Last means at first I just try to plus 6, then 5 6, then 4 5 6, then 3 5 3 4 5 6, 2 3 4 5 6, in this way. So for that, obviously, like after 6 I have to bring 5, I have to bring 4, then 3, then 2, like in this way. And and yeah, like so if while I'm taking the 3, then if 2 is if 3 just placed before 2, this is 3 and this is 2. So in that case I have to choose 3. But if this is the case, 3 and 3, then I don't have to choose 3, because if I choose 3, then it will automatically come 2 3 and 4 remaining present. Let's suppose the remaining element in sorted order. If I choose to 2, then this also in remaining order, so that's will reduce our number of steps. So yeah, like that's why I was taking or I was considering the number in just adjacent. Yeah, right. So yeah, like this is the solution for the second problem. And yeah, like if you have any doubt, let me know in the comment section. I'll happy to help you. Yeah, let's just now we'll discuss the third problem. Okay, so bye.